Okay, my pre-calculus friends, I know this modeling with sine and cosine has been a beast. Let's tame it and conquer it. Starting with number 14 on your review guide. The number of hours of daylight measured in 1 year in Ellenville can be modeled by a sinusoidal function. During 2006, which is not a leap year, the longest day occurred on June 23rd with 14.8 hours of daylight. The shortest day of the year occurred on December 22nd with 8.1 hours of daylight. Write a sinusoidal equation to model the hours of daylight in Ellenville. Let t be in terms of days. Use a cosine function and be sure to calculate the phase or the horizontal shift. Okay, so we noticed they gave us a maximum. They gave that to us right here. The maximum is 14.8. And they also told us the minimum, which is right here, 8.1. Now if you look at your notes that has all the work for this on it, or how to work this, you can use this to find the amplitude. The amplitude is found by subtracting the max, or max minus min, and then dividing by 2. And that gives you 3.35. You can also find the midline by doing the max plus the min over 2, and that gives you 11.45. So that's our vertical shift. It's also our D. So once you have your max and your min, the A and the D should be pretty straightforward. It's those two formulas every time. Now the next step would be to find B. B is 2 pi over the period. Now we're talking about the length of days over the course of a year. So a year is our period, but you notice it does say to let t be in terms of days, so we need to say it's 365 to put it in terms of days. So our B is equal to 2 pi over 365. Okay, now I know this next part is the one that gives lots of people cramps and despair. So you need to remember the formula. C is equal to B times the shift. So we've actually got part of it already covered. We already know what B is. We found that a second ago. It's 2 pi over 365. So now we just need to multiply that by the shift. So let's go back into the problem and see if we can sort that out. Okay, they told us the longest day, which would be the maximum number of daylight hours, was on June 23rd. So one option, and this would be completely fine, would be to figure out the number of days it takes to get from the beginning of the year to June 23rd. You could add 31 days of January, 28 of February, 31 of March, and so on, all the way till 23 days of June. Add those all together and shift that many days forward or to the right. Same idea. That would be completely fine. That's one legitimate way to do it. To me, it's simpler to just shift backwards to December 22nd. So you can kind of think of midnight on New Year's Eve or New Year's Day, however you want to think about it, the transition there as the time 0. So if we're transitioning back to December 22nd, then we could say December 31st, that's 1 day back. The 30th is 2 days back. The 29th is 3, 28th is 4, 27th 5, 26th 6, 25th 7th, 24th 8th, 23rd 9th, and I think I just counted it wrong. Sorry, let's do it this way. December 31st back 22 is a distance backwards of 9 days. Sorry, I'm overcomplicating this. We just need to think December 31st is the end of the year, so we need to back up 9 days, go to the left, backwards 9 days. So we're shifting to the left 9 days. So a shift left of 9. So now, once we simplify that, 2 times 9 is 18 pi over 365. We have all the letters we need. We have our A, our amplitude, our D, our B, and our C. So let's put this all together. The amplitude is 3.35. Sorry, just 1 second. 3.35. And we are using cosine. Our B is 2 pi over 365. Don't forget to put the variable in there. I'm going to use t for time. Our C is 18 pi over 365. Okay, we're shifting to the left because remember we're thinking about kind of the end of the year, December 31st, and shifting back 9 days to December 22nd. So since we're shifting to the left, if you think about a timeline, you're shifting to the left backwards to December 22nd. To the left means we add, and then we add our c, which is 18 pi over 365, and then our d goes on the end, plus 11.45. One last thing, when you're dealing with cosine, if you start at a maximum, then you make the whole equation positive. If you start at a minimum, which is what we did by backing up to December 22nd, you have to put a negative out front. So you just got to remember, if you start at a minimum, you got to put a negative out front. If you start at a maximum, you leave it positive. Next up, number 15. The typical voltage, V, supplied by an electrical outlet in the United Kingdom is a sinusoidal function that oscillates between negative 105 volts and positive 105 volts. So they've given us the max and the min. The max is 105. The minimum is negative 105. And they told us that, well, actually, let's pause there. Let's go ahead. Once we have the max and the min, just like before, we can go and find the amplitude by doing the max minus the min over 2. That's going to give me 105. And I can find D, the midline, or the vertical shift, same thing, the D, by doing the max plus the min over 2. And that's going to give us 0. So we actually have no vertical shift at all. The midline is just going to be at 0, which is the x-axis. Alright, so we've done what we can with the max and min. That's find our A and our D, and that's good. Now we can find B by doing 2 pi over the period. If you notice, they actually told us the period was 1/50th of a second. So we can put 1/50th at the bottom here, because it's 2 pi over the period, 2 pi over 1/50th. And to divide by a fraction, we multiply by the reciprocal, so we get 100 pi. And then our best friend C is equal to B times the shift. So that's 100 pi for B times the shift. So let's go back here. They actually don't give us any information about when it starts, when it stops, when it's at the maximum, when it's at the minimum. So we can just assume, which is nice, that there's no shift. Shift to 0, which just means that all gets wiped out and you don't have to include it. If they don't give you information about when the max or min is or when it starts or stops, then you don't have to worry about a vertical shift. So we can write our equation as 105 for the amplitude. You can use sine or cosine. It didn't specify and we don't know where we're starting, so either one's fine. Of 100 pi t. Please don't forget that variable. We don't have a D because that ended up just being 0, and we don't have a C because we didn't have any information about a shift. (16) You are riding a Ferris wheel with a diameter of 40 feet. So notice, this one, unlike the one we had on that worksheet, is giving us the diameter. So all the way across is a distance of 40 feet. When the last seat is filled and the ride begins, your seat is at the lowest point on the wheel. So you're beginning down here at the minimum. It takes you 4 seconds to reach the top, which is 43 feet above the ground. So they're telling us that at the top we're at 43 feet. So if you pause right there, that tells you that the bottom seat is exactly 3 feet above the ground. Because if that top right here has to be 43 feet high and the Ferris wheel is 40 feet high, that must mean an extra 3 feet is how high the Ferris wheel is above the ground. So once we have that part of the picture, we can see the maximum is 43 and the minimum is 3. So just like before, if you get your maximum and your minimum, you can find the amplitude. Do the max minus the min over the 2, you get 20. You can find your vertical shift or your midline by doing the max plus the min over 2. Should be 23. Sorry, computer's slowing down on me. Hopefully it'll catch up now. Alright, this might just pause for 1 second. I'll be right back with you. Okay, hopefully it's back to normal now. Okay, so we found our A and our D. Now let's talk about B. B is found by doing 2 pi over the period. Okay. Whew. Now, they told us that when we start at the bottom, it takes 4 seconds for us to rotate up to the top. Also, it says the wheel makes 1 revolution every 8 seconds. So that's actually the only part we need. 1 full revolution every 8 seconds. That means the period is 8 seconds. So we can put 8 in here. Because we do 2 pi over the period, 2 pi over 8. That reduces to pi over 4. Okay, so we've come to our most fun part, C. C is equal to B times the shift. Well, our B is pi over 4. And our shift, well, if you look, it says we start at the minimum. We start at the bottom of it. So we actually don't have to shift at all because we're already at the minimum at time 0. So our shift is again 0. So we have no horizontal shift, no phase shift. Okay, so we can now write y equals, we write the amplitude, which is 20. We'll use cosine because we're starting at a minimum of pi over 4 t, and the d is 23. Okay, time to hit our last one. A motion detector is facing the floor as it revolves around a circle. The following graph of height versus time was obtained following this collection of data. Use Sine to find a mathematical model for the circle and explain the meaning of each value. Alright, I think I did on your sheet adjust that and said I wanted you to do cosine instead of sine. So we will do a cosine function. So let's look. We'll just focus on these 2 points right here. We won't worry about the rest just to keep things simpler. We can see there what the maximum is. The maximum is the y value, 1.94. The minimum is the y value at the bottom, which is 0.46. So just like before, we can find our A by doing the max minus the min over 2. That's our amplitude. It turns out to be 0.74. We can find our D, our vertical shift, our midline, by doing the max plus the min over 2. And that gives us 1.2. So once you find your max and your min, that A and the D should be very straightforward. Works the same every time. Now to get the period. Well, we notice the maximum up here is at time 0.75. The minimum down here is at time 1.25. So it takes half a second. 0.75 to 1.25 is 0.5, or half a second, to go from the maximum down to the minimum. Well, that's half of a cycle. To get a full cycle or full period, we need to go back up, which is going to take another half second. So our period is 1, which means B is equal to 2 pi over 1. So we finally come to our favorite part, C. Okay, bear with me. C is equal to B, excuse me, B times the shift. We just found B. It was equal to 2 pi. Now we've got to figure out the shift. So let me clear this out a little bit for us, make it easier to see. We said we're doing cosine, so it makes the most sense to look at a maximum or a minimum. Now you can do either one. I'm going to shift over to the maximum right here, this point, because it's a little closer, and it's at 0.75. So if you think about it, we are starting on the y-axis. That's where we wanted to start, but it didn't. It's been shifted over to 0.75. So it's been shifted to the right 0.75. So the shift is 0.75. So we do 2 pi times 0.75, which is 3 pi over 2, or 1.5 pi. Either way. So now we have all of our pieces. We do the amplitude times cosine, our b times x, and since we're shifting to the right, we subtract our c value, which is 3 pi over 2, and at the very end we add our d, 1.2. And that tells us how this motion detector is moving. Please study this. If you have to rewatch this or retry some of the worksheets, please do it. You can do this. I want you to try hard and be successful. So please work hard and do your best.